So does it work? Oh, okay. So hello everyone. My name is Michael, and I'm representing Intel MPI. I'm an Intel Cluster Tools architect. Intel Cluster Tools primarily includes Intel MPI. Okay, I will talk about the the interaction between Intel MPI and LibFabric today. The first slide I'll show you it's marketing slide, and don't pay much attention to the exact wording, but it's just for to start the discussion. I should mention Brian's talk from Amazon. He mentioned about the difficulty of supporting different implementation of TCP stack, and Intel MPI was driven mainly by a need to support different multiple fabrics, and we supported them for a long time. Primarily, it's just a few interconnects like Ethernet, Mellanox InfiniBand, and lately it's QLogic, TrueScale, and Intel Interconnect. It's PSM facing interconnect. So there is only a few interconnects that we historically supported, but we needed to support a lot of infrastructure around that fabrics. So just to be exact, we in the current generation of Intel MPI we support TCP netmod, we support WinTCP netmod, we support double netmod, we support netmod for some reason it's called OFA, it's IBWorks netmod. We support TMI netmod, we support OFI netmod. So it is the whole zoo of netmods. So like 3 years ago, we came to the idea that probably many of you thought about. Why don't we go to the one fabric, and if we have such a fabric that could support any single interconnect that we want to support. So fortunately, we have those time. There was a first effort to bring up LibFabric. It called differently those time, but now we called it LibFabric or OpenFabric interface. It doesn't matter. So this is the first slide. This is the first page from LibFabric side, and of course, from Sean talks, you are quite familiar with what it is, and many of you is just active members of OFI-WG working group. So you know exactly what it is. What Intel MPI wanted from LibFabric, and what it is very essential for us, it is that it has all the capabilities set that we need to support different interconnect, and moreover, it is a capability-driven fabric. That is what is important for us for Intel MPI. For any given capabilities we want to exploit, we just check if the exact provider supports this capability, and we go to the direct path that assumes that this capability is present and working, and so on. And we very it's very attractive that this is a lot of, not a lot of, but a number of types of endpoints supported. And this is very important for us because we support different types of interconnect. The primary reason for us to choose LibFabric was that scalability feature for LibFabric. Generally, what we based for the current generation, we based on MPICH implementation that assumes a number of virtual connections support in software, and it limits scalability a lot. With LibFabric, we need to have just a few bytes per connection per connection to be present, like FI address. This is 8 bytes containing the address of peers, all the peers. Okay. So what is what is the brief history of Intel MPI and OFI collaboration? Intel MPI was among the first runtimes that adopted LibFabric, and we created the first. We supported the early adoption of LibFabric back to 2015, and in 2016 we go to LibFabric as a primary interface for Intel network, and in the past year we released so-called technical preview of the new generation, of the new library generation based on MPICH-CH4. This is a new device for MPICH based on OFI. And this year we're releasing beta, 2019 product beta these days. It's around the corner. And we're going to release the gold release of this library version just in the second half a year. What we want to get with this library. So first of all, you know that all the net mods that we supported in the previous generation of our library, we remain supporting these networks in different way via LibFabrics. So we continue supporting Windows, and we'll support Windows with fast interconnect, actually over Mellanox. We will support TCP as well via LibFabric sockets, and everything that mentioned here. Okay. What is the general architecture of the next generation product? Perhaps the text is too small, but the first rectangle is called abstract device interface. It's a MPICH term just showing the high-level abstraction. And this is a picture. This is generally MPICH architecture that is adopted by Intel MPI. And the next talk will be about MPICH and LibFabric support by MPICH, and perhaps there will be more details about MPICH. So, as I stated on the previous slide, we will continue supporting Ethernet, InfiniBand, and Intel interconnects. And we are preparing to future interconnects. And what's particularly interesting in this design, that we are primarily ready to easily adopt the new interconnects. And we hope that as Amazon creates the LibFabric provider in that capabilities that is enough for our implementation, we'll just easily will run on that interconnect. And there may be a couple of few examples. And for instance, Cray provider will help us to easily run on that hardware. Okay, so what we are using from LibFabric, what kind of features and what kind of capabilities. So the primarily use of endpoints, the type of endpoints that we are using, this is reliable datagram endpoints, but we have a workaround for other type of endpoints. Not just workaround, but it's in the end of the slide. It's the last bullet. We have so-called utility providers, and we use extensively RxM, in particular for Network Direct, and we are going to use RxD as soon as it is stable enough for instance, for UD on Mellanox, and for other probably networks. So RDM is our main main endpoint type. What we are using extensively now is scalable endpoint features from LibFabric. I will talk a little bit more about scalable endpoint support. The next talk from Pitch they will talk about scalable endpoint support as well, but we support it differently in Intel MPI, and we made it absolutely in performant way for the multi-threading support via scalable endpoints. We primarily use tag data transfer, but we have different so-called active message path for another data transport, for just legacy message data transfer using memory regions and so on. We support, of course, RMA data transfer. We use thread domain level of threading that makes the provider run at full speed. we use memory region and different style of address vector. And I mentioned it a little bit for RxM and RxD utility provider. We used them specifically for that type of networks that provides different types of endpoints. So we are using it on Mellanox and for reliable connected via RxM, and we are going to use it for UD as well. Okay, a little bit about scalable endpoints. Perhaps I don't know how many of you know what is scalable endpoints in LibFabric, but generally it's for us it's a good abstraction to save a lot of space of the address vector. Generally, we have on the init stage we create multiple receive and transmit contexts. We bind completion keys to that context, and basically we get just independent channels. We create independent channels to fabrics, and we efficiently use them from multiple thread mode. So we for our implementation, Intel MPI implementation of the thread multiple, we use some special programming model that is based on the per thread communicators that allows us to get separate queues for different points and assign them to different threads, so we can go absolutely lockless on threads. So we have in Intel MPI we have performance or in thread multiple model, which is almost equivalent to the performance from single thread in multiple processes. That's all due to the usage of scalable endpoints of LibFabric and appropriate scalable endpoints implementation in the PSM2 provider for Intel OmniPath. But it is not limited to Intel OmniPath, and with the proper implementation of scalable endpoints in different providers will have the same feature over these providers. Just an illustration of our programming model with in multiple threads. Generally, we base on different communicators that used from different threads, and different communicators, they just bound to different contexts of the scalable endpoint, and this way we can make it absolutely parallel. Okay. So generally we like that OFI features that we use in MPICH and in Intel MPI, and there's no particular reason for us to complain about performance using libfabric, but there could be some extensions that help us to not only to improve some performance, but make our life easier in terms of implementation of some communication operations like collectives. Collective operations, it's like a sweet spot for us. Just for example, we cannot get the full performance out of different kind of interconnects very easily. So Mellanox has FCA, and we used to support FCA one time. It was quite painful for us. We just it took some resources for us to implement FCA, and it was quite not quite good implementation. And one time FCA changed from version 2.5 to 3.0, and we had a major problem, and we just stopped supporting FCA efficiently. What if we have some umbrella interface for collective operations in libfabric that allow us to jump to different providers that could implement their collective operations in their own preferred style, whether it is offload collective operations or software-based collectives or triggered operations. That is kind of point of discussion. We don't have a group notation in libfabric. We don't have this or that, but generally I had some naive implementation of some sort of schedules that lead to implementation of collective operations for Intel OmniPath, and it can give quite good performance. That's all I wanted to talk about. Questions? Okay, thank you.